Next, another one is the first order reactions. First order kinetics, first order reactions. First order reactions. So I mentioned that in the earlier one, when A2 products formation takes place, the rate of reaction which depends upon the concentration of the one reactant molecule A, that is considered as the first order reactions. Earlier one I explained that. Now at time t is equal 0, suppose we may imagine the initial concentration of the reactant molecule is A, there is no product, suppose 0. After some time, so while reaction is going on, or reaction takes place, in the course of the reaction, suppose X is the product formation takes place, and A minus X is the left, the reactant molecule is left, A minus X. A is the initial and X it may be formation, A minus X is the reactant molecule is left. How much reactant molecule is left? A minus X. How much product formation is X? So in the first order kinetics, I mentioned that earlier one, that rate constant is the K1, is the rate constant or velocity constant is K1. According to that rate of reaction, dx by dt, generalized purpose, the rate of reaction dx by dt is directly proportional to the concentration of the reactant molecule, how much is left, A minus X, concentration of the reactant molecule, A minus X. When proportionality is removed, we have to use one constant, that constant is K1, rate constant of the first order reaction, rate constant is K1, K1 into A minus X. If this one will be written as 1 by A minus X into dx terms are one side, and K1 into dt is going to be another one side, and both sides we have to take the integration, and integration derivation is cancellation takes place, and integration 1 by A minus X into dx, that value which is going to be L and A minus X. Integration 1 by x into dx is log x, log x. So by using this mathematical principle, integration 1 by x into dx, here in this x plus 1 by A minus X is there. So ln A minus X and d by dx of A minus X, d by dx of A is 0 and dx by dx is there, minus value is there. So that means here it is d by d, integration 1 by A minus X is log x, integration 1 by x into dx value is ln x, based on the formula we have been written. Suppose this is x, and ln x into d by dx of x, if it is cancellation takes place, 1 is there, that value is ln x actually. Now here in this case 1 by A minus X is there, so in the place of x, A minus X is there, so that's what we have to use, ln A by A minus X into, here it is A minus X. So d by dx of A is the concentration of A is different, so this value is 0, and minus d by dx of x is there, so dx by dx is cancellation takes place, so what will be happen, minus ln, in place of x what we have to take, A minus X. If it is integration 1 by A minus X into dx will be taken, minus ln A minus X, right? That is the mathematics, according to the mathematics, right? So I just mentioned earlier one, the mathematical principles, very beginning, in the quantum mechanics point of view, check that. So minus ln A minus X, why this minus is obtained, this minus X is there. So, and K1 into integration derivation is cancellation takes place, t, we have not applied any limits, so we have to use some integration constant. This IC is the integration constant. Limits are not applied, integration constant. Suppose this is equation number 1, integration constant. In this case, at time t is equal 0, at initial time t is equal 0, the product x is also 0, there is no product, x is 0, is substituted in equation number 1, substitute in this equation number 1, so then what will happen, minus ln A, x value is 0, that is equal, K1 into time t is 0, this one is 0, what will happen, that is integration constant IC. This is equation 2. Again this equation 2 is substituted in equation number 1, this equation. In the place of IC, integration constant, we have to substitute minus a. So that means minus ln a minus x, ln means base e, is equal k1 into t minus ln a minus ln a. If this was shifted to the right side, so what will happen? Minus ln a minus x. This was shifted to the right side, minus is going to be positive, is equal k1 into t. This is one equation. Suppose this is equation number 3. And this equation number 3 can be written as positive term, can be written as before. Suppose minus ln a minus x is equal to what? K1 into t. K1 into t. This is log a minus log b form. So I mentioned that earlier one, log a minus log b is there, log a by b. So that's what ln a by a minus x, that is equal k1 into t. ln a by a minus x is equal k1 into t. This is one of the equation. Suppose this is equation number 4. And our requirement is k1, rate constant of the first order reaction, k1 is equal. So how to write this? 1 by t, this t is going to be right side, 1 by t into L and a by a minus x. A by a minus x. Or in the place of ln, suppose we have to use log. So that means k1 is equal, how to write this is 2.303 log. ln base e is equal 2.303 log base 10, 2.303 by t log a by a minus x. In terms of log a by a minus x. So this is the first order reactions, rate constant k is equal 2.303 by t log a by a minus x. So this one is also important because in the graphical points of view, so this middle equation is also important. Right. So this is one type of method we have to use, or else some other methods also we have to use. Which one? In the case of the reactant molecule concentration, suppose we have to consider, this is generalized purpose dx by dt. Or other one, if you can use the specific part, suppose reactant molecules concentration, or another one method. So reactant molecules concentration A is decreases with the time t, is directly proportional to the concentration of the reactant molecule A minus x. So that may be depends upon concentration of A minus x, instead of that concentration of the reactant molecule A. Concentration of the reactant molecule A is directly proportional to the A. But this one is also like that. After reaction it maybe takes place. So this is the concentration of the reactant is decreases and A. Different methods are there. So if here it is minus dA is equal, minus dA by dt is equal, suppose k1 is the rate constant into A, and if it is shifted to the right side, minus 1 by A into dA is equal, this is shifted to like this, k1 into dt. If both sides we have to apply the integration and limits can be applied, this is concentration of A is changed from A to A minus x. Suppose directly I can apply here in this position, and time is 0 to t. What will happen? Integration 1 by A into dA is like that, 1 by x into dx is ln x minus ln A. These concentrations will be changed from A to A minus x, that is equal k1 into this integration derivation is cancellation t and 0 to t. What will happen? Minus in the place of A, what we have to substitute? A minus x one time, another one time A, that is equal to one time is t, another one time is 0. So what will happen here in this case? Minus, this is minus ln A minus x. From this what we have to use? ln A minus ln B, or this will be minus and minus into minus is plus. So this will be written as, this is one type of equation. So this equation will be considered as an minus ln A minus x minus ln A is equal k1t. This is one specific equation is there. Or This is when multiplication takes place, minus, and this is minus into minus is plus. This will be written as what? ln a minus ln a minus x is equal k1 into t. Again this method, ln a minus x is equal k1 into t. So then if it is takes place, what will happen? K1 is equal 1 by t into ln a by a minus x. Again this one method is also, we have to follow same thing. You can use this one or this one, similar one it may be there. K1 is equal 1 by t ln a by a minus x. Sometimes instead of the a, this rate constant k is equal to what? 1 by t ln a by a minus x. In the place of a, sometimes will be given C0. C0 is the initial concentration. And if a minus x is equal to C, suppose will be given after after product formation, how much concentration is left? C. Based on that, this reaction is also sometimes will be mentioned. K1 is equal 1 by t into L and a plus C0 by C. C0 by C also, which is there. This equations, it may be different. Right, C0 by C. And sometimes this equations also it may be changed. This is one type of equation. If A is equal to C0, A minus X is equal to C. Suppose. And sometimes K1 is equal to 1 by T L and A is the initial concentration. That initial concentration it may be considered as, suppose A naught, that 0 time 0, this concentration of A is A naught. And after some time, this concentration of A is A. After some time, A, concentration of A after some time. After that time, completion after the reaction. So in a particular time. So here it is 0 time and at time t. Based on this also sometimes will be given L and A naught by AT is equal, what is that? K1 into T. Ln A naught by AT is equal K1 by T, or ln C naught by C is equal K1 into T. Then ln A naught by AT, so this is A naught by AT is equal to what? A naught by AT is equal, this ln is going to be right side, exponential factor. Exponential factor is also there. So this will be written, so here in this case, I can mention in this at this position. So this is the rate of reaction in the first order kinetics point of view. First order kinetics point of view. Right? So you listen what will be happen here in this case. From this, ln A naught by AT is equal K1T. Then that will be written, suppose this numerator and denominator will be interchanging takes place. Before what will happen? Minus at time t, concentration of A at 0 time, this is reverse takes place, minus is happening. So that is equal K1 into T, and this will be shifted to the right side. What will be happen? AT by A naught is equal minus K1 into T. So then ln, if it is going to be right side, which will be happen, what will be happen? So base E, AT by A naught is equal exponential factor minus K1T. If it is log is there, 10 to the power of ln base E, this is going to be exponential factor. Then at time t, the concentration of the reactant, so time t is equal, so if it is shifted to the right side, A naught into e to the power of minus K1 into T. Or C is equal C naught into e to the power of minus K1T. If it is C naught and C will be there, suppose. C naught and C will be there. C is equal C naught into e to the power of minus K1T also you may be written. Right? Or here in this case A minus X is equal A into e to the power of minus K1T also. If it is similar one, it may be there. Is nothing but the A minus X or C. This is A naught, sorry, A or C naught. Right? So now here in this case, in this equation sometimes we will mention, if average lifetime if average lifetime is tau, average lifetime tau is equal to 1 by rate constant, 1 by rate constant, or this is going to be right K inverse also. K inverse or 1 by K. This is the average lifetime. When average lifetime tau is equal to 1 by K, so here in this case, tau 1 is equal to 1 by K1, or if time t is equal to the 1 average lifetime, 1 tau, time t is equal, in first order kinetics, the lifetime, so the time of the reaction, the time t is equal 1 average lifetime, 1 tau. Suppose that is equal to the 1 by K1, that is equal to the 1 by K1. Then what will happen? AT is equal A0 into exponential factor minus K1 into, in the place of t, tau, that average time is, it may be average lifetime, suppose that is equal 1 by K. Here in this case 1 by K1. So if it is cancellation takes place, what will happen? AT is equal to A0 into e to the power of minus. So based on that, AT is equal to what? A0 into 1 by E inverse, or 1 by E, like this, right? Or if time t is equal, suppose 2 tau is there, time t is equal 2 tau, what will happen? 2 by K1 if it is there. When 2 by K1 if it is there, what will happen? If suppose time t is equal to average lifetime, suppose if t is equal to tau, so that is equal to the 2 into 1 by K1. Tau is equal to 1 by K, that is the rate constant is 1 by K1. So based on that, what will be what we have to substitute in the place of time t, tau, the 2 tau is equal to 2 by K1. Suppose AT is equal A0 into e to the power of minus K1 into, in the place of t, tau, in the place of t, 2 tau, that means in the place of 2 tau, 2 by K1, suppose. So what will happen? E to the power of minus 2. AT is equal A0 into e to the power of minus 2. E to the power of minus 2, or what we have to substitute e to the power of minus 2, or e to the power of minus 2, or 1 by E square. 1 by E square we have to substitute, 1 by E square, or AT is equal A0 into 1 by E square. In problematic point of view, we have to use actually, right? So this type will be there. Any one methods we have to use. Now K1 is equal, the units are what? Units are, first order units are what? Rate constant units. So what is that? 1 by T into ln A by A minus X. A is nothing but the concentration, initial concentration. A minus is also, X is also initial concentration of the reactant, how much it is left. So this is concentration like this. So time it may be considered as an T, time inverse, suppose that it may be minutes, seconds, hours, whatever it may be, we can take, into, this is concentration units are moles per liter, concentration and concentration. So this is moles per liter, and this is also moles per liter. Is cancellation takes place, or concentration is cancellation takes place. What will be happen? K1 is equal time 1 by time. So that means K1 is equal, what is that? Time inverse. The time it may be hours or seconds or minutes. K1 is equal second inverse, if we can take seconds, if we can take minute inverse, hour inverse, whatever it may be, time inverse or second inverse units, right? So the first order units are time inverse or second inverse. Now another one more, suppose we have to take the average lifetime, sorry, not average lifetime already we have seen. Half lifetime is what? Half lifetime or half-life. Number of half-lifetimes. So number of half-lifetimes or half-lifetime you can consider here in this case. Similar like the earlier one, half-life can be shown like this. Which one? T half is the half-life. So earlier we have seen when concentration of the reactant molecule, if it is going to be half, how much time it is required, that it may be half-life. So A is going to be A by 2. That means X is equal to A by 2. When T is equal T half, then what will happen? X is equal A by 2. Initial concentration is half, it may be takes place. How much time it is required? A is the initial concentration, it is going to be half. The time required is the half-life. Then if X is equal to A by 2, then T is equal to T half. So you know that K1 is equal to what? 1 by T ln or 2.303 by T log A by A minus X. And in the place of X, suppose we have to substitute A by T, A by 2. And if T is equal to T half, then X is equal to A by 2, then log A by A minus A by 2. That means A minus A by 2 means 2A minus A by 2. 2 into A minus A by 2 whole part. So that is equal 2.303 by T half log A by 2A minus A by A means A by 2. So this is what? Which one? A by B by C type it may be there. So that is equal A into C by B, AC by B. Right? So based on this, what we have to use? 2.303 by T log, this is shifted to the denominator, this A by 1 into 2 by A type. So that means here it is 2A by A, this it maybe takes place log 2. And log 2 value, according to the mathematics, log base 10, 2 value, log 2 value is 0.3010. So that means 2.303 by T, so this is T half. Log 2 value is how much? 0.3010. This is K1 is equal. That means K1 is equal 2.303 into 0.301 is 0.691. 0.693. How much it is the half-life? 0.693 by K1. So because 1 into 3 is there, so 3 here in this case. 0.693. 2.303 into 0.3010 is 0.693 by T half. Alright, this is one of the formula. Then T half is equal to what? 0.693 by K1. First order rate constant. This is half-lifetime. Half-life, T half is equal 0.693 by K1. 0.693 by K1. K1 is the first order rate constant. Now here in this case, like the earlier one also I mentioned that zero order case. Now here in this case, the half-life in the first order is not depends upon the concentration. There is no concentration term. 0.693 by K1. K1 is the rate constant, is a constant. So this first order reactions case, the half-life time it is not there. So half-life is independent on, T half is independent on concentration, dependent on concentration of reactant. So it is not depends upon the concentration. Independent on concentration. It not depends upon concentration. Independent. right? Independent, right? So not depends upon the concentration. Concentration is not depends upon, right? So this is the half-life of the first order reactions, right? Next one, based on this, what we have to calculate, some of the graphs will be there, and suppose depending on the half-lives, the number of half-lives are there, number of half-lives, T-halves, and how much concentration is left. So concentration of reactant remaining, how much is left or how much is remaining, that is A minus X, in which of time how much is left, how many number of times how much concentration of reactant is left, and concentration of product formation or formation of product, this is X, how much product formation takes place in half-life times. If it is 0 half-lifetime, if number of half-times are 0, so there is no half-time. Concentration of reactant is A, initial concentration, and there is no product, 0. At 0 half-life. So number of half-lives are 1 half-life if it takes place. So how much concentration is left? Reactant is left, A by 2. A by 2 is left. So the A by A is suppose 100%. Suppose you may imagine you can imagine A is 100% initial concentration. So how much is left? 50% is left. And how much product formation takes place? A by 2. This is also 50% in first half-life time. So number of half-lives are 2. Number of half-lives are 2. Then how much it may be left? A by 4. A by 4. Again, this is going to be half. So that means how much? 25% is left. How much which is formation plus 25%? That means here it is 75%. That is 3A by 4. If A is 100%, 300 by 4 is 75%. So this is the second half-lifetime. If it is number of half-lives are 3, suppose 3 half-lives are there, how much it is going to be? Again half it may be there. Again half means 12 by 25 is going to be half, 12.5. So that means here it is A by 8. So A is 100%, that is how much? 12 by 12.5%. This is how much? 12.5%. A by 4 or 12.5%. A by 4, A by 8, sorry, 12.5, A by 4, 25, A by 2, 50%. Whatever it may be, you can use. So this is in percentages form. This is A by 2 in percentages is like this. So this is how much here in this case? A by 8 is there. So here it is 7A by 8. How much we can add? Again 12.5% you can add. So how much it is there? 83.75%. 83.75%. Sorry, 12.5% is left. How much? 87.5. So you can add 12, that is 87. 87.5 is there. 87.5%. 87.5%. If suppose another one half-life is there, 4 half-lives are there, how much is left? A by 16 is left. That A by 16 means again half. That means 6.125%. So again this one is addition to this 6.125. So that means here in this case, how much it is left? 15A by 16. How much here in this case? 6.125 you can add. So 93.725, 93.7 something, 93.75 it may be there. 93.75 it may be there. 5%. Right. So 93.75% is product formation. So like this it may be there. So how to remember this? Suppose in 0 time this is happening. In 1 half-life, this is a by 2, this is a by 2, you know that. Half-life time, if it is 1, half of it maybe takes place. If 2 half-lives, number of half-lives are 2 suppose, so this is square, a by 2 square, a by 4. When a by 4 is left, how much it is formation? So how much it is? 3a by 4. a by 4 plus 3a by 4, total one which is equal to the a. So like this, a by 4 is left, that means how much? 3a by 4. If a by 8 is left, how much? 7, out of 8 parts, 1 part is left. So how much it is there? 7a by 8. And here out of 16, 1 part, that means how many parts? 15a by 60, right? So like this, after n half-lives, suppose after n half-lives, n half-lives are there, the reactant is left, the concentration of reactant A minus X is remaining, concentration of A minus X remaining is equal to A by 2 to the power of n, A by 2 to the power of n. Suppose 2 half-lives, n value is 2, suppose how much concentration is remaining or how much concentration is left? A by 2 square, that is A by 4. If 4 half-life times takes less, A by 2 to the power of 4, that is 16. Like that it may be there. So if you know that A by 16, how much is remaining? 15a by 16, 7a by 8, 3a by 4, a by 2 again. Right? So this is happening here in this case. Right? So this is the half-life, number of half-lives, how much concentration is remaining, how much product formation takes place in the first order case. Now again the graphical representation, we have seen the graphical representations. So because sometimes graphical point of view also questions are there. So problematic problems also there in the graphical point of view. This is the half-lives concept. Right? If A is 100%, this A by 8 or 7A by 8 like this. This is A by 2 or 50%, 3A by 4 or 75%, not product. In 75%, this is a 7A by 8 or 87.5% in product in percentage format. If A is equal 100%, that one is there. Right? Because whatever the concentration beginning that we have to consider, that is 100%. Based on that, how much it is going to be product formation, how much it is left or remaining. Right? Next, another one, the graphical point of view, some of the graphs which is there. See, we know that K1 is in the earlier, at the beginning, dx by dt is equal K1 into A minus X. This equation we have seen already. Dx by dt is equal K1 into A minus X. Based on this K1 into A minus X, K1 into A minus X, if the plot between dx by dt and A minus X, dx by dt, y is equal mx time. A minus X, concentration of reactant left, A minus X. So this type of plot will be there, and x-axis and y-axis. So the plot slope which is equal to the, which one? K1, rate constant K1. Y is equal mx type graph is there. And we know that another one, 1 by t into ln A by A minus X. And based on this, suppose ln A by A minus X is equal, what we have to write? K1 into T. K1 into T. So by using this, suppose the plot between ln A by A minus X versus time T. Suppose in the plots between ln A by A minus X versus time T, in the x-axis time, y-axis is this one. Which one is the slope? K1 is the slope. Slope is equal K1. Or sometimes will be mentioned the plot between log A by A minus X versus time T. if log will be written, so if log will be written, what will happen? 2.303 by t log a by a minus x. So log a by a minus x is there, or 2.303 log a by a minus x, ln plus 2.303 log. So log is equal k1 by 2.303. So from this we have to return log a by a minus x is equal, or 2.303 log, this 2.303 is going to be right side, k1 by 2.303 into t, then y is equal mx type plot based on this. So this is also passing through the origin. So slope is equal to how much? k1 by 2.303. This is one type of graph is there. And sometimes the plot between log a minus x by a versus time t. How to show this plot? So this is reverse takes place. What will happen? You have to add minus. You have to use minus. You have to use minus. So or log. So you know that a minus x, log a minus x versus log a minus x minus of log a. So earlier one I just mentioned, log a minus x minus log a is equal k1 t is there. So this is shifted to the right side, minus k1. Then log a minus x by a is equal minus k1 t. Or from this reverse takes place, suppose you can take this one principle. This one is reverse takes place, log a minus, this is denominator and numerator interchanging, minus is addition. So this is shifted to the right side, what will happen? Log a by a minus x by a is equal. So this is here in this case. If it is, this is interchanging takes place, minus you can add. What will happen? Minus k1 by 2.303 t. If ln is there, k1. Log is there, minus ln is there, minus k1. Only if log is there, by 2.303 is addition. So that means the plot between log a minus x by a is versus time t, y is equal mx type. So what is the slope? Slope is equal to minus k1 by 2.303. If a minus x by a plot, it may be there. A minus x by a plot. Right. So this type of plots we have seen in the case. And suppose log a minus x versus t plot, if it is there. So you know that log a minus x is equal k1t, or from this suppose we know this formula, ln, suppose you have to use ln a minus x by a is equal minus k1 into t, only ln if it is there, not 2.303. From this, if it is interchanging takes place, you can add minus. So here you can add minus, this minus is shifted to the right side, minus k1. From this is a by b, suppose if it is there, log a minus x minus log a is equal k1t minus k1t, and this is shifted to the right side, ln a minus x is equal, this is minus k1t plus ln a. Suppose the plot between y is equal mx plus c type, if it is there, plot between ln a minus x on y axis, ln a minus x versus time t plot, time t. How to show that? So here it is, some negative slope will be there, slope will be the negative slope will be there. Here this slope will be the negative slope. Here it is. This slope will be the negative slope. Here it is negative value. This slope is the negative value. So that's what. In the earlier one, I just mentioned minus is there here in this case. Slope is negative value, right? So here it is also slope is negative value. How much is the slope? Minus K1, and this intercept which is equal to the how much? ln A. Intercept is ln A, this part. ln A, slope is equal minus K1. So like this type of plots will be there. If you can draw the any one plot between any one values, given values, and different plots will be mentioned, right? In the first order concept, first order reactions. The first order reactions concept, the plots will be there. So this is minus means what will be happen? Here in this case you have to imagine this is 0, this values will be negative, like this type of curve. Here it is also, this value will be 0. Like this is type of curve will be there, right? Minus. Above is positive, below is minus, right?